I'm Lakshman Singh Rawat, PGT Chemistry, teaching in Cambridge International School, Daswa. In this hour of crisis, CIS Daswa has come up with e-learning so that you do not miss out on academics in this lockdown also. Students, we will carry out with a basic concept of chemistry only, and this will be my third lecture. Students, I hope you have seen the previous lectures. Now today also we'll continue with some basic concept of chemistry. Student, today also we'll continue with the international system of units, and in this we will be discussing about some commonly used physical quantities, and then we'll discuss about the uncertainty in measurement, and in that we'll be discussing about the scientific notations and the calculations that will be involved in the scientific notation. First of all, we'll discuss the prefixes used in the SI system. Now listen, in the case of SI units, some of the physical quantities are either too small or too large. Now in order to change the magnitude, these are expressed by using prefixes before the name of the base unit. Now how this is done, we'll be discussing it. Listen, here we have 10 as deca, 100 as hecto, 1000 as kilo, and then as we move toward the decreasing side, we'll see that after one we have the 10th, okay, that is deci, 100th is centi, and 1000th is your milli. That means if we are moving toward the left in the place value chart, the value increases by 10 times. For example, we will discuss about meter here. Let us suppose the unit that we have taken is meter. The moment we move toward the left, it becomes decameter, and decameter is 10 times of 1 meter. Okay, and as we move toward left, we get the hecto. Hecto is 10 times that of decameter. That means it is 100 times, 10 into 10 times of 1 meter. Okay, and then as we move toward kilo, toward the left, it becomes 10 times of hectometer, and that is equal to kilometer. Okay, that means from meter, 1 meter to kilo, the magnitude has increased by 1000 times, that is 10 into 10 into 10. And now as we start moving toward the right, you'll notice that after 1 meter we have the 10th of meter, that means 1 upon 10. Okay, and that is called your decimeter. Okay, next one is your centimeter. Okay, centimeter is 1/10 of decimeter, that is your centimeter, and millimeter is 1 upon 10 of centimeter, that is millimeter. So if we move from meter to millimeter, it becomes 1 upon 1000 of a meter. And here you must have seen that meter and centimeter are related as hundredth. Okay, that means centimeter is your 1/100th of a meter, or you may say that 100 centimeter is equal to 1 meter. Now that we have discussed about the prefixes used in the SI system, let us discuss some commonly used physical quantities. First of all, we'll discuss the mass and weight. Now, what is mass? The mass of a substance is the amount of matter present in it. Okay, while weight is the force exerted by gravity on the object. As a result of which, what will happen? The mass will remain constant everywhere, whereas the weight, it will change from one place to another, and it will be happening because the gravity is changing. Okay, weight is the force exerted by gravity on the object, as a result of which if the gravity changes, then the weight will also change. For example, a person weighing around 60 kg on earth will be weighing 6 kg on moon. And this 6 kg is possible if we suppose the gravity of moon to be 1/10. Okay, but in actual the gravity of moon is 1/6 of the gravity of earth. So what will be the weight of a person weighing 60 kg on earth on moon? What will be his weight on moon if he is weighing 60 kg on earth? If you have guessed it as 10, then it is correct. The weight of the person will be 10 kg on moon. Okay, but remember, the mass will always be equal. Now I will try to explain you how. Listen, the weight can be measured by spring balance, whereas the mass will be measured with the help of your physical balance. Okay, now 60 kg means, let us suppose you are putting 60 stones of 1 kg, okay, on one side, and a person is standing on other side, then they both are equal. Okay, that way we will be measuring what mass in actual. Now if we take a person to moon, okay, then the mass will be always equal. That means the 61 kg stones will be equal to the person on moon also, on a physical balance. But if we measure the weight of that 60 stones of 1 kg on moon, it will be showing how much of weight? Yes, it will be showing 10 kg of weight. And similarly, the person will also be showing 10 kg of weight. However, in that 10 kg, how many 1 kg stones are there? There will be 61 kg stone. So the mass has not changed, but the weight has changed.
And weight measure the same thing. Close, but not really. The mass of an object is a measure of the number of atoms in it. The SI unit for mass is the kilogram. Weight is a measure of the force that gravity is pulling on the same object. Gravity is a force and technically should be measured in newtons. A newton, represented with capital N, is equal to the acceleration of 1 kilogram 1 meter per second per second. Your weight can change based on the gravitational pull of your location. For example, you weigh less on the moon than on Earth. Mass is a measure of how much matter something contains, and weight is a measure of how strongly gravity pulls on the same object. The SI unit for mass is kilograms. The SI unit for force is newtons. Thanks for watching.
After seeing that small video clip, you must have understood what is weight and what is mass. Now let us try to understand what is this volume. Okay. Now, it is a quantity of substance in a space of length cube. That means if you are holding a substance in three-dimensional space, okay, which has got length, breadth and height, then the quantity of substance in that three-dimensional space is called volume. So since it has length into breadth into height, the unit becomes length cube. In SI system we call it as meter cube. However, commonly we use the term litre also, which is not an SI unit, but still we use it for measuring the volume of liquids. Now next one is density. What is this density? Density is the amount of substance per unit volume. Okay, that means if we define it, it is the amount of the mass per unit volume, and the SI unit of density is kg per meter cube. However, this unit is quite large and we often use gram per centimeter cube for density. Another type of physical quantity that we often use is temperature. Basically, temperature measures the heat energy, or it measures the degree of hotness. Okay, now we commonly use three scales to measure temperature. The first one is your degree Celsius, second one is your degree Fahrenheit, and the third one is your Kelvin scale, which is also called the thermodynamic scale of temperature. Okay, and the SI unit of temperature is your Kelvin. Now, how are they related to one another? The Kelvin scale is related to Celsius scale as follows: K equal to degree Celsius plus 273.15. That is the precise value. Normally for our calculation we may use 273 only also. Okay. Now, for example, if we have 0 degrees Celsius, then in Kelvin scale it becomes 273 Kelvin. Clear? Or let us suppose if in the degree Celsius scale the temperature is 300 degrees Celsius, then in Kelvin scale how much it will become? Yes, it will be your 300 plus 273, that is equal to 573 Kelvin. Clear? Now, in the case of Fahrenheit scale, how it is related to the Celsius scale. The Fahrenheit scale and Celsius scale are related as follows. Degree Fahrenheit is equal to 9 by 5 degrees Celsius plus 32. If possible, find out the temperature at which the degree Celsius and the Fahrenheit temperature are equal. Please see the video clip which will give you the detail of the three scales of temperature.
Measurement of temperature. Temperature is defined as the degree of hotness or coldness of a body. We can feel the effect of heat when we sit near a hot body. The instrument which is used to measure the temperature of a substance is called a thermometer. Thermo means heat and meter means measurement. A thermometer works on the principle that a liquid expands on heating and contracts on cooling. Temperature scale. A liquid thermometer have a bulb at one end and a long stem which is graduated in degrees. The scale of a thermometer is usually divided between 2 points. One is melting point of pure ice, 0 degrees Celsius, and the other is boiling point of pure water, 100 degrees Celsius. These 2 points are called the lower fixed point and the upper fixed point. In general, measurement of temperature is divided into 3 scales: Celsius scale, Fahrenheit scale, and Kelvin scale. The Celsius scale of temperature was designed by Anders Celsius, 1701 to 1744. The unit of measurement of temperature in this scale is degree Celsius, 0 degrees Celsius. The lower fixed point of the scale, ice point, is 0 degrees Celsius, and the upper fixed point, steam point, is 100 degrees Celsius. The interval between the lower fixed point and upper fixed point is divided into 100 equal parts. The value of each division is 1 degree Celsius. On the Fahrenheit scale, the lower and the upper fixed points are 32 degree Fahrenheit and 212 degree Fahrenheit respectively. The distance between these 2 points is divided into 180 equal parts. Each division is equal to 1 degree Fahrenheit. The different types of thermometers are: 1. Clinical doctor's thermometer. 2. Laboratory thermometer. 3. Maximum and minimum temperature thermometer. In thermometers, the sensitive liquid used in mercury because it is a shining liquid. In maximum and minimum thermometer, the liquid used is alcohol. Clinical thermometer. It is also called the doctor's thermometer. It is used to measure the temperature of the human body. It measures the temperature in Fahrenheit scale. It consists of a thin capillary tube having a small cylindrical bulb at its lower end. The bulb and the part of the capillary tube is filled with pure mercury. There is a small bend in the tube called constriction, kink, just above the bulb. When the thermometer is placed in the patient's mouth below the tongue or under the armpit, the mercury expands. It pushes through the kink into the capillary tube. The kink ensures that the mercury does not move back into the bulb when the thermometer is taken out of patient's mouth. This gives us time to take the reading after removing the thermometer from the patient's mouth. After taking the reading, mercury can be made to return to the bulb by giving jerks to the thermometer again and again. Laboratory thermometer. A laboratory thermometer is used to measure temperature in the laboratories during various experiments. Generally, it is graduated from -10 degrees Celsius to 110 degrees Celsius. When the bulb is heated or cooled, mercury in the bulb expands or contracts and rises up or goes down through the capillary tube. The mercury can be seen through the stem as a thin shining thread. Mercury is preferred to other liquids as it is a liquid metal, good conductor of heat, and expands uniformly. Maximum and minimum thermometer. You must have seen the maximum and the minimum temperatures recorded in various metropolitan cities on your television screen. Similarly, most newspapers give the maximum and minimum temperatures of a city for previous day under the heading of weather report. This thermometer was invented by James VI in the 18th century. Therefore, it is named after him as Six's thermometer. This thermometer measures the minimum and maximum temperature attained during the day. It is used by the meteorologist to record the highest and lowest temperature of a place on a given day. Unit of temperature. SI unit of temperature is Kelvin, K. 0 degrees Celsius is equal to 273 Kelvin. 100 degrees Celsius is equal to 373 Kelvin. Scientist. Daniel Gabriel Fahrenheit, 1686 to 1736, was a German physicist, engineer, and glassblower who is best known for inventing the alcohol thermometer 1709, the mercury thermometer 1714, and for developing a temperature scale now named after him. According to Fahrenheit's 1724 article, he determined that scale by reference to 3 fixed points of temperature. The lowest temperature was achieved by preparing a frigorific mixture of ice, water, and ammonium chloride, a salt, and the reading there was taken as 0 Fahrenheit. The second reference point was selected as the reading of the thermometer when it was placed in still water when ice was just forming on the surface. This was assigned as 32 degree Fahrenheit. The third calibration point was taken as 96 degree Fahrenheit when the instrument was placed under the arm or in the mouth.
Now, what is this uncertainty in measurement? In chemistry, we deal with data, and the data of experimental and theoretical calculation needs to be handled carefully, and the data should be presented realistically with certainty to the extent possible. The data recorded are presented in scientific notation. Now, what is this scientific notation? In scientific notation, or This is also called your exponential notation. Any number can be represented in the form of n into 10 power n, where the small n is an exponent and it can have the positive or negative values, whereas the capital N can vary between 1.000 to 9.999. That means if we have to write 232.508, then in scientific notation it can be written as 2.32508 into 10 power 2 in scientific notation. Okay. Now you must have noticed that while writing the number in scientific notation, the decimal had to be moved to the left by 2 places, and the same is the exponent 2 of 10 in the scientific notation. Similarly, 0.00016 can be written as 1.6 into 10 power minus 5. Here what is happening? The decimal place has to be moved 4 places to the right, and as a result minus 4 is the exponent in the scientific notation. So what we see is the power of 10 is same as the decimal places which has shifted. Okay, it can be either negative or positive depending on which direction we are shifting the decimal places. Now let us understand how do we carry out the operation, mathematical operation in scientific notation. Now first of all we'll discuss multiplication and division. Okay, and in these two cases the rules remain same. The first example that we have taken is multiplication of 5.6 into 10 power 5 with 6.9 into 10 power 8. So what we'll do is we'll bring the terms together. We have arranged 5.6 into 6.9 together and 10 power 5 into 10 power 8 together. Okay, so you'll notice that in the second bracket the bases are same. That means 10 is the base, 10 is the base, and the powers are 5 and 8 respectively. Okay, so if the bases are same, powers will be added. So in the second step what we have done is 5.6 into 6.9, and for 10 we have added the power 5 plus 8, that comes out to 10 power 13, and when we multiply 5.6 with 6.9 the result is 38.64 into 10 power 13. Now if it has to be expressed in scientific notation, that is in the form of n into 10 power n, then we will be writing this answer in term of 3.864 into 10 power 14. Okay, so what we have done is, since we have shifted the decimal place to the left, the power has increased by 1. Okay, since the decimal is shifted by one place, so the power has also changed by 1 unit. We will take another example involving the negative power of 10. Now here look at the example. 9.8 into 10 power minus 2, and that is multiplied to 2.5 into 10 power minus 6. So we have arranged the terms together. We have arranged 9.8 into 2.5 together into 10 power minus 2 and 10 power minus 6 together. So when the bases are same, powers are added. So we have already added the power. Okay, so it becomes 9.8 into 2.5 into 10 power minus 2 plus within bracket minus 6. That is, this becomes 10 power minus 8 in the next step, and when we multiply 9.8 into 2.5 in the next step, it becomes 24.50 into 10 power minus 8. Now in scientific notation we write this one as 2.4 2.50 into 10 power minus 7. Okay, now we have shifted the decimal place toward left, okay, by one place. So what we'll do is we'll add plus 1 to the power. So when we add plus 1 to minus 8, it becomes minus 7. So the answer is your 2.450 into 10 power minus 7. Now let us discuss the division. In the case of division, we have taken here example 2.7 into 10 power minus 3 is divided by 5.5 into 10 power 4, and this is written as equals to 2.7 divided by 5.5, right close. Okay, now when we bring 10 power 5 as a numerator, it comes with negative sign. So when the bases are same, powers will be added. So it becomes 10 to the power minus 3 minus 4. Okay, and when we divide 2.7 by 5.5, the answer comes out to be 0.4909 into, and the 10 becomes 10 power minus 3 minus 4 is minus 7, and in scientific notation it can be written as 4.909 into 10 power minus 8, since we have shifted the decimal place to the right. Okay, so what will happen? We will subtract minus 1 from the power, so the powers will be added and it becomes 10 power minus 8. Now let us try to understand how addition and subtraction is done. First of all, we'll discuss addition, and remember that for these two operations, first the numbers are written in such a way that they have got the same exponent. That means first of all what we do is, if they have got different exponent, that is powers of 10, we equate them or we make them equal. Then only after that we carry out the operation. After that the coefficients are added or subtracted as the case may be. Okay, we'll take up first the addition. For example, if we have to add 6.65 into 10 power 4 with 8.95 into 10 power 3. First of all, what we'll do is we will make the powers of 10 equal. Okay, so if here we are making the power as 10 power 4, okay, then the first term will be as such, we'll be writing the first term as such only. In the case of second term, what we will do is 8.95 into 10 power 3 will be written as 0.895 into 10 power 4. That means if we multiply 10 to 0.895, we will get the previous number back again. That is, if we multiply 10 to 0.895, it becomes 8.95. Okay, so ultimately the numbers are remaining same, only we have shifted the decimal and changed the exponent. Now we can add the terms as we are doing it below. Okay, now look here. Here, since the powers are same, okay, the bases are same and the powers are same, so these two terms are together, are common. 10 power 4 and 10 power 4 of the second term are common. We will take this one out of the bracket and add 6.65 with 0.895. okay, and when we add it, the answer comes out to be 6.65 plus 0.895 comes out to be 7.545, and the exponent term remains as 10 power 4, and this will be the answer. Now similar to the addition, the subtraction is also done. Here we have taken two numbers, 2.5 into 10 power minus 2 minus 4.8 into 10 power minus 3. That means 4.8 into 10 power minus 3 is being subtracted from 2.5 into 10 power minus 2. Okay, and this is equal to, what we do is first we will make the powers equal. Okay, so we have put them in brackets first. 2.5 into 10 power minus 2 minus, instead of writing it as 4.8, we are writing it as 0.48 into 10 power minus 2. Okay, so we have shifted the decimal place toward the left in the second term. Okay, so the power, what we'll do to the power, we will add plus 1 to the power. So it becomes 0.48 into 10 power minus 2. So we have equated the powers in both the terms. Okay, since the exponent become equal, we can take it as common. So we have in the second step 2.5 minus 0.48 and 10 power minus 2 is common in both the terms. So when we subtract 2.5 minus 0.48, the answer is 2.02 into 10 power minus 2, and it is in the scientific notation also. So this much for today. We will be discussing about the significant figures and its calculation in our next lecture. Till then, revise everything properly,